All right, so now we're just going to do some absolute value equation examples. So if you did not watch the intro video, watch that because you won't understand the steps I take here unless you've watched that video. So reminder, when I get an absolute value problem, I need to check to make sure that the absolute value bar is alone on one side of the equation. In this case, it is. I check to make sure that it doesn't equal a negative number, right? Which is good here. And then I split into two cases. So I can say, hey, 2x minus 1 could equal 5, or 2x minus 1 could equal negative 5, right? Because negative 5 is also 5 away from 0. And all we have to do is solve, add 1, we get 6. X equals 3, add 1, x equals negative 2. So we get two solutions, and then you go back and you check them by plugging them into the original and making sure that it makes the equation true, which in this case they both do, right? Let's try another one. First step is we need to get the absolute value bars by themselves. So go ahead and add 1 to start and divide by 3. Now I can be like, okay, it doesn't equal a negative, and I'm going to split into two cases. So x plus 2 could equal 3, and x plus 2 could equal negative 3, okay? Go ahead and subtract 2. Go ahead and subtract 2. And take your answers, plug them back into the original, check them, and we should be good to go. And I'm actually going to wait on number 3 because it's a little bit more difficult. I'm going to jump down to these examples. All right, so let's see. Number 4, it's already solved for the absolute value bars. I'm going to split into two cases. So let's see, 4x minus 1 equals 19. So 4x equals 20. So x equals 5. Or 4x minus 1 could equal negative 19. So 4x could equal negative 18. So x equals negative 18 fourths, which equals negative 9 halves. Uh-oh, that went crazy. Which equals negative 9 halves. So that is a solution. And if you plug those back in, it gets messy, but they both still work. All right, number 5. I'm going to check. It's already solved for. It doesn't have a negative number. So I'm going to split into two cases, okay? My first case is just 3x plus 5 equals 14. My second case is 3x plus 5 equals negative 14. So 3x equals 9, and x equals 3. 3x equals negative 19, so x equals negative 19 thirds. And again, check your answers. Both of these work. Now, the reason why your answer could not work is because you forgot to check for negatives. So you should be good to go if you have already checked for negatives, but always check just to be sure. All right, so I'm going to try example number 6. I'm going to have to scoot over a little bit. Okay, so example number 6. The first thing I need to do is get that absolute value bar by itself. So I'm going to add 5 to both sides. Negative x plus 3 equals 4. And then divide by 4. So negative x plus 3 equals 1. So the absolute value bars alone, it doesn't equal a negative number, so I can split into two cases. Negative x plus 3 equals 1. Negative x plus 3 equals negative 1. Subtract 3. X equals 2. Subtract 3. And x equals 4. And both of those work. So now the only issue is going to happen like in example number 3. Okay, so look what happens here. This one's tricky. So the absolute value is solved for, so I can split into my two cases. My first case is that, but my second case, I need to make the whole opposite side negative. Because there's variables, it makes it a little bit harder. So take negative 4x plus 5. So you need to change the sign of everything on the other side, not just the first term. So this is my case number 1. This is my case number 2. All right, so let's solve them. I'm going to subtract 3x. subtract 5, so x equals -3. And then let's see, add 4x, 7x plus 2 is -5, so 7x is -7, so x equals -1. All right, so then what we do is we have to check our answers. Again, always, always, always check our answers. So look what happens. If I plug in, I'm going to choose a different highlighter. If I plug in -3 here and here, I get, let's see, the absolute value of -7 equals -7. Well, the absolute value of -7 is actually just 7. And this is not true. So this is not a solution. This is an extraneous solution. So you always have to check your answer. Let's try the other one. If I plug in -1, over here I would get the absolute value of, let's see, -1 equals 1. This happens to be true. So this one's okay. So you have to check your answers just in case you get something. It's really important when there's a variable on the right side. That's when it's particularly important to check your answers. So just be thinking about that. All right. Can you write an example of an absolute value equation that would have no solutions, right? That is just, I want to make sure you know that it cannot equal a negative number. So you can write anything as long as it doesn't equal a negative number. So